Angela. Yep. Where'd you go? There you are. Yeah, so maybe, yeah, let's do the first one, and then I'm going to put the picture up there. So it takes a little longer to get down to the, say the last bit again. I didn't. Right. Okay. I'm not reproducing this at all. I'm sorry. Let's look at what we're doing here. So yeah, so we have, there's an upward buzz and there's this downward buzz. So the first thing is just this pitch idea. So to me this is pretty intuitive, but I think you just have to get your head wrapped around it. But the idea would be that this one would be kind of going, so it's going up, becoming as you go up in frequency, whereas this one that's going down, and this one's going down also, would be more kind of a sound. Probably wouldn't sound exactly like that, but that's the idea, is that we're decreasing in pitch, right? And then this one certainly, this buzz is about maybe not quite twice as long as this one. So this would here sound like a little quick burst because this is 1 full second here. So this is maybe 1/5 of a second, whereas this is probably more getting into the 1/4 of a second, maybe a little bit longer territory. And I could probably find examples of this, but we're going to do a lab. Unfortunately, it's much later in the semester. It fit there in my brain for whatever reason to do it that way. But it will fit there nicely because it'll be when we're talking about communication and mate choice and that kind of thing in class. But we'll really be dissecting and analyzing bird songs later on. But I just wanted you just to think about what these spectrograms actually mean. That was the point of that one. All right, so how does figure C2, I guess we would say, show, what does figure C2 show happen to the minimum frequencies of songs from 1969 to 1998? What'd you put? I think it's still you. I'm going to summarize that more briefly, but whoops. That's this one. Yeah, so certainly there's some variation, which is kind of interesting, but we see this sort of upward trend where the minimum frequency is going up over time pretty substantially. I mean, almost 1/2 kilohertz or so. There was this bit, how would this have been determined on the spectrograms in figure C1? Did you get anything for that? Like, so if that's C1, I think. Like what is, maybe I'm, oh no, I'm wrong. Yeah, it's this bit. So what is depicted, like what's the link between this one and this one, I guess is what I was trying to ask. And this can go for anybody. It doesn't just have to be Angela. But like what is this figure showing? And how would you get it from this? Does that make sense? So what is this? It's frequency. What do we mean by frequency here? Is it just frequency? Is it range of frequencies, maximum frequency, minimum frequency? Do you remember? I think it's minimum frequency, isn't it, that they're plotting? Or am I out to lunch here? Does that sound right?
My understanding was that the bottom of each block is
the minimum frequency?
And then the top of it would be the maximum.
Yeah, I thought maybe that was more like showing variation. I could be wrong. I remembered this as being minimum frequency, and I've read this paper too. so the question was kind of how do we link across? If this is showing the range of frequencies across the song, then you would be basically looking at what's the maximum versus the minimum here and cutting across that range. I thought what they were actually doing though is recording this for a bunch of birds. So maybe there's 47 birds in the sample, and then basically going in here and looking what's the minimum frequency in this spectrogram. So you kind of find the lowest point and then trace over and report what that number would be. That's my understanding of what they were doing, because they're really interested in these low frequency sounds for this study. Whereas for these guys, these are more looking at the green ones. Again, you're kind of going in and looking at the lowest possible frequency, but it's kind of hard to see on these scales because they're compressed, but we're seeing an increase in the minimum frequency, not so much a change in the high frequency, which are up or 6 kilohertz region, but the minimum frequency is increasing over time. Does that sound right to anybody? Or you just give me the benefit of the doubt, maybe? Whatever you want, man. That's fine. All right. Yeah, so I think it's shows increases in pitch. I'm just going to add this, that it's minimum frequency. Okay, so last question. So based on questions raised in the text in box 2.1, why might this shift in minimum frequency shown in C2 have happened? What'd you get? Whoa, not happening. Expanding. So there's an excess amount of noise from these cities, so that might be causing the shift in their as they're trying to get away from urban noise. Does anybody have anything they want to add or differences, or what kinds of frequencies are urban noise frequencies? It did mention this. It was sort of, you had to dig a little bit and look, but like what noises do humans make? What'd you get? Yeah, it's usually these low frequency sounds. So there's excess amount of noise from these cities. I'm going to put especially low frequency noises. So these are engines and car tires and all the kind of just white noise of the urban environment that that you hear. Those, if you measure them, a majority of them are in this range starting around 3-ish, 2.5-ish kilohertz and going down. They don't tend to be up here. And so the birds, what they seem to have done is shifted their dialects to avoid the sounds down here that are overlapping in frequency with the urban noise. And instead they've adopted higher frequencies because this is a little bit more of a clear channel where they can actually communicate, not be drowned, not have their sounds drowned out. So this seems to be a shift that has occurred as urbanization has occurred around these white-crowned sparrows, and they have learned and adopted different dialects. So we've seen kind of a social evolution happen within these groups as they prefer, basically they're preferring dialects apparently that work better in their environments. Cool? It's a really neat, I think urbanization is a really interesting question. I think we tend to like to study ecology in like pure and pristine environments, but there's very few of those anymore. A lot of really interesting questions anyway are how do animals live around the fact that humans change the environment so much? I don't know if you guys knew John Woloschuk. Do you guys know John Woloschuk a couple of years ago? That's kind of like what he's studying. His lab that he went to at Bowling Green, he's in a master's program there, but all they do is urbanization studies, and he's working on something about bats and urbanization and bats. Oh shoot, and we're out of time. So we will have to stop. We don't have time to do this next one. So we will start the next class with the quiz, and then after the quiz we'll resume discussion of Chapter 2 homework, and then I hope we will be able to start in Chapter 3 as well that day. So you